Okay, we did equations. Now, how about these things called inequalities? Well, you'll see this a lot too, and you'll see probably more inequalities than equations in real life if you think about it. But an inequality can be used to model a situation that describes a range of numbers instead of a single number. In all of our previous lessons in Chapter 6 here, we always got just one answer for x, a single number. But now with an inequality, we actually can get more. Now, reading an inequality depends on the symbol that's used. We always read from left to right. In this case, the symbol is greater than. So this is A is greater than. Please write this down. B. The second one, when the sign is reversed, so the pointy end is pointing to the smaller number, so A is less than or smaller the number B. Notice in this case I've got a greater or equal to, so now this time A is greater than, and then here's the extra piece, greater than or equal to the number B. And the last one, of course, is A is less than. And once again, that extra line underneath means or equal to B. So, I'd like you to take a look at example number 1, and I want you to determine if the following inequalities are true or false based on what we just learned about. So from part A, is 0 less than or equal to 6? I certainly would hope so, because I'd rather have $6 than nothing. So true. In this case, -4, is that bigger than -2? So think of -4 as you owe someone $4. And think of -2 as you owe someone $2. Which would you rather owe, -4 or -2? Hope you said -2, so that's the bigger one. And of course that means that this equation or this inequality is false. Another way you can do this one, once again, is to draw that number line. So here's -2, here's -4. Remember, the bigger one is always to the right. So in this case, -2 is bigger. How about this one? 7 is less than or equal to 7. Well, 7 is not less than 7. We know that. But it is equal to. And this says less than or equal to, so therefore it's true. And 0.3, is that bigger than 1/3? 1/3 as a decimal, I hope you remember, is just 0.3333333333333 repeating. So it has more stuff. It's a little bit more, so I guess this one must be false. Now, I told you we see inequalities a lot in real life, so let's take a look at some of these. People that are 16 and older can drive. So once you turn 16, you can get your license, or at least your learners. So I'll call P people, and it's 16 and older, so it's bigger than, but because once you turn 16, you don't have to be like past 16, you can be equal to 16 and still get your license. The symbol here is P is greater or equal to 16. Speed limit is 55. Well, you don't want to go over it, but you can be right at it, so you want something to be less than or equal to 55. To store this below 4 degrees Celsius, so whatever temperature you have, you want it to be below, so that must be less than. You don't want it to be equal to, it says below 4, so how about T is less than 4? Okay. Now, how do we visually show inequalities? So if we're asked for a solution of the inequality x is greater or equal to 2, what's your answer? Well, really, an answer is a number that's x, which is greater than or equal to 2. Now, how many answers are there? Well, it could be 2, it could be 3, it could be 4, it could be 5, it could be 10,000, it could be 10 billion, it could be 10 gazillion. So there really is an infinite number of answers. So we can't really list them all, because we just can't. So we represent all of these answers by using a number line. In this case, 2 is actually part of our answer. Is included because of that equal sign. So to show that it's included, we draw a solid dot at 2. So a solid dot means we include that particular number. And you want to extend the line in the direction of the answers. In this case, it's greater than, so I'll extend it to the right. So we think about it, all the values that are 2 or more get shaded in, and those are my answers. Okay, that's the visual representation. Okay, turn the page. What about this example? T is less than -5. What am I talking about here? I'm saying give me all the solutions to numbers that are less than. But this time there's no equal sign, so just less than -5. And because there's no equal, that means -5 is not part of our solution this time. And so we draw an open circle to show that it's not part of our solution. And then we extend the line in the direction of our answers. It's less than, so we're going to the left. Or if you think about it, it's highlighted. And once again, open dot. Okay, open dot. So, can you now do some practice? I've given you 3 inequalities. You go ahead and try to graph them on the number line now. Go. Equals -2, so we have to put the solid dot. Greater than, going to the right. 4, no equal sign, so open dot. Less than, going to the left. 0, right here, dot including, open dot, but going to the right. That's it. Now, that's a single inequality, but lots of times there are what we call double inequalities. And these involve a range that fall between 2 given numbers. In this case, the no parking signs, you can't park between 9 a.m. and 6 p.m. So this is a combination of 2 inequalities. You can't park between these 2 times. So you can't park between 9 a.m. or more than 9 a.m., so bigger than or equal to 9 a.m., and less than 6 p.m. Now let's use military time, 6 p.m. Remember 12 hours in a day, so I can add 12. That's the same thing as 1,800 hours. So I'll say it has to be less than 18 as well. Algebraically, what does this look like? Well, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I want everything in between and including. So my answer actually looks like this. All the shaded part between 9 and 18. And at 9 and 18, solid dots. Okay. Well, example 4 is just some more practice with now double inequalities. This is a little bit more tricky. Please read the questions carefully, and let's see if you can find the answers. Once again, try them first, then come back and double check with me. Bill loses between 1 and 4 pounds. Wow. Between 1 and 4. Now, between means it has to be in between, not including, so we'll leave it as an open dot and everything in between. Okay? Temperature today will be at least 2, so that includes the 2, solid dot, but less than 5. Doesn't include, so like this. 1 can be solid, 1 can be open, and shade everything in between. A number is not between -1 and 3, so -1's over here. I didn't put it on there. So the opposite of not between -1 and 3. If it was between 1 and 3, that's A, right? Like this. 1 and 3. And we shade everything in between. But this is the word not, so it's the opposite of that. So therefore, the opposite of that would be over here. And remember, between means you don't include, but this time not opposite. So therefore, we want to include the numbers -1 and 3. There you go.